Intro Algebra Lesson 5-5A. Now that we've spent quite a bit of time dealing with slope-intercept form, and that's a really good form to use anytime we know the slope and we know the y-intercept, or we can easily find the y-intercept. The slope-intercept form of y equals mx plus b is a great form. But sometimes it's a little cumbersome to take the slope and the point and substitute it in for y equals mx plus b and solve for b. And so it would be nice to have another form. And today we're going to talk about another form that works for linear equations. And it's maybe a better form to use based on some different information that might be presented to you. For example, point-slope form is great anytime you know a coordinate and you're given a slope. Hence the name, point-slope form. You'll notice it's y minus y sub 1. Here's your slope again, and x minus x sub 1. So a couple things about the variables. We know for a fact that we'll be able to put the slope here, because that's what we were given was the slope, so we'll put that value in for m. But we're also given a point, and all coordinates are made up of x and y. So when you look here, you'll notice there's two y's and there's two x's. Well, we actually want to substitute the value in for the sub 1 x and y. So whatever point we're given is going to go in for x sub 1 and y sub 1. We're actually not going to put anything at all in for the regular x and y. Nothing's going to go here, and nothing is going to go here. So the values that we will substitute in will be here, here, and here. We will plug in three pieces of information into our formula. Alright, so let's just say hypothetically that you had a coordinate of 5, 4 and a slope that was equal to 3. Just to keep numbers nice and simple. This is your x sub 1 value, and this is your y sub 1 value. We have an equation of y minus y sub 1 is equal to the slope times x minus x sub 1. So our x value of 5 is going to go here. Our y value of 4 is going to go here, and our 3 is going to substitute there. We will not put anything in for the y or the x. So our final answer could look like y minus 4 is equal to 3 times x minus 5. Or, if you would like to manipulate the plus negatives, you could say plus negative 4 is equal to 3 times x plus negative 5. There's no real difference between those. So this is point-slope form. We were given a point, we were given the slope, we plug it into point-slope form. Now what's interesting is, if you actually take this form right here, and I'll bring it down here so that it's for something more we can look at, you can, within two steps, change it into another form that you're familiar with. The 3 can be distributed. So now you end up with y plus negative 4 is equal to 3x plus negative 15. And then all you have to do is add 4 to both sides. And you will have your good old friend slope-intercept form. So point-slope form is 2 steps away, a distributed property and a shuffle, from having y alone and being y equals mx plus b. So there's some absolute relationships between the two. But right now, we're just going to concentrate on using point-slope form. So let's just say we were given a graph, and on this graph are 2 coordinates. So again, we're always going to need slope. So you have the choice of using the slope equation, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. You could use that equation, or you can count rise over run. If I use the equation, then maybe this right here is x sub 1, y sub 1, x sub 2, y sub 2. And I'm going to use my formula. And I'll say 6 minus 2 over negative 4 minus negative 2. Which I will change to plus the opposite and plus the opposite, giving me 4 over negative 2. Which means it goes up 4 and left 2. Up 1, 2, 3, 4, left 1, 2. It definitely looks like it goes up 4 and left 2, so this slope seems reasonable. This can be simplified down. You can leave it as a fraction 4 over negative 2, or you could say negative 2 over 1, or you could just say negative 2. So we'll use negative 2. And then we need one of the coordinates, it doesn't matter which one, And we'll use our y minus y sub 1 is equal to the slope times x minus x sub 1 formula. So my y minus this y is going to be y minus 2 equals the negative 2 for my slope, x minus negative 2. Now I need to be careful that I watch my signs, so it might be beneficial to make that y plus negative 2 is equal to negative 2 times x plus 2. So that's one possible answer. But you could also have chosen the other coordinate. There's nothing that says you have to use that one. So we could have used the minus 4 for the x and the 6 for the y. So we would say y minus 6 equals negative 2 x minus negative 4. So that's the other coordinate involved. In which case, it might be more beneficial to make that y plus negative 6 is equal to negative 2x plus 4. So if I use one coordinate, these might be my options. If I use the other coordinate, these might be my options. You don't have to do both. Either of them are the same. Now some people will say, but those aren't the same equation. How can they be the same answer? If you actually use the two steps like we did here to create slope-intercept form, you would find they are the same. Right? A quick little test here. If you distribute, you get y plus negative 2 is equal to negative 2x plus negative 4. You would then add 2, and you would get a slope-intercept form of y equals negative 2x plus negative 2. Now, unless this is different, then they're basically the same equation. So up here, if I were to distribute, then I would end up with y plus negative 6 is equal to negative 2x plus negative 8. And I can add 6, and we get a final answer of y equals negative 2x plus negative 2. Exactly the same equation. So even though we chose different coordinates to use in our point-slope form, this form right here, they still produce the exact same answer in the end. So either of these are good, either of these are good in point-slope form. All right, one more. Write an equation in point-slope form. We know that that's y minus y sub 1 is equal to the slope times x minus x sub 1. And look what's been given to us. All the information we could need. So again, that's x sub 1, y sub 1. So we say y minus negative 3 equals our slope of 4 times x minus negative 1. And then you might want to go plus positive and plus positive for a final answer of y plus 3 equals 4 times x plus 1. And that's all it's asking us to do. It's not asking us to convert it into slope-intercept form. It's just saying write an equation in point-slope form. So we use that point and that slope, we substitute it in, and we have our equation. We're still 2 steps away from making it slope-intercept form, but this is all it's asking us for right now.